Today we are going to be solving systems of equations by substitution. So last week we solved by graphing, and that way works well, except when the problems end up having a fraction as a portion of the answer, or if the numbers are very large. So this is another method that works with all types of problems, and it's one that's used quite often when a variable is like y or x is by itself. In this case here, we have a system, and we have y equaling x plus 3, but also y equals 2x plus 5. So the substitution works this way. If y equals x plus 3, let's just take that x plus 3 and let's put it in for y in the other equation. So when we do that, we still have this x plus 3, but now it equals, instead of y, since y equals also 2x plus 5, we'll set the x plus 3 equal to 2x plus 5. So from that point, we just have an equation with variables on both sides. So to solve that, we just isolate the variable x. So I'm going to take away x from all sides. And since I eliminated the x's on the left-hand side, I'm going to move the constants over to that left-hand side. So what I'm left with is x equaling negative 2. Well, that's only the x component of the ordered pair. We still have to find the y component. So we're going to take this negative 2, and we're going to substitute it back into one of these two equations. The easier of the two would be this one, because all we have to do is add 3. In the other one, we would have to multiply by 2 and then add 5. Either way you do it, you're going to get the same answer. So we'll just go ahead and write down y equals, and in place of the x, I put negative 2 plus 3. So we can go ahead and combine those two numbers. That leaves us with 1. So y equals 1. So the way we write the answer is an ordered pair. And we'll write it as negative 2, because that's the x value, and then 1 is the y value, with parentheses around the two numbers. So there's one problem. Here's a different type. What makes this different is that, first of all, x is by itself, and also both aren't equal to x. Only one of them is. So what we're going to do is take that expression that x is, which is that y minus 5, and we're going to substitute it. We're going to put it in place of the x in the equation below. So once we do that, we'll rewrite our equation. Now this time we've got a coefficient in front of the variable that we're substituting that expression in for. So we have to put the expression, the y minus 5, in parentheses. Again, the y minus 5 equals x. So I just substituted it, but it needs to be multiplied by the 4. So that's why it goes in parentheses. And then I just bring everything else down. I bring down the plus y, bring down the equal sign, and the 20. Well, from that point, I'm going to go ahead and multiply the 4 over this difference and see what's left over. So I go ahead and do that. Now I've got 4y minus 20 plus y equals 20. Well, a couple more steps there. I can collect some like terms. On this side, I can go ahead and combine the 4y and that positive y. And also, at that same time, I'm going to go ahead and add that 20 to both sides. So the 4y plus the 1y gives me 5y. And this all equals now 40, because 20 and 20 made the 40. Well, from that point, I need to get rid of that coefficient of 5. So I'm going to do another opposite operation. I'm going to divide by 5. And that's going to give me 8. So y equals 8. Well, that's only one component. We need to find both components of the ordered pair. So now, once we've done that, we have to take that value of 8 and substitute it back into one of these equations. I could have put it in this one down here, but that would require me to bring it to do an opposite operation and then divide by 4. Here, all I have to do is subtract the value of 8 from 5. So I'll rewrite what I've got. X is going to equal, and again in place of y, I'm going to write down 8 minus 5. And that gives me 3. So I write the answers in ordered pair. 3, 8. And there's our answer. Well, here's another example. This time, in order to use this method of substitution, I need to do an opposite operation to isolate the variable. So looking at these two equations, I need to solve for either x or y in one of the equations. This one would require a couple of steps. This one only requires one step. So I can isolate the x easiest. So that's what I'm going to end up doing. I'm going to add this 4y to both sides of the equation. So I'll go ahead and rewrite what I've got. Now x equals positive 4y plus 11. Plus because there was no sign in front of the 11, so we treat it as positive. So once one of the variables is solved for, now I can use the substitution method, which says I can take the value that that variable is, x equals the 4y plus 11, and we're going to put it in place of the x in the other equation. So now once we've done that substitution, we can rewrite our new equation. It's going to be 4y minus 5 multiplied by 4y plus 11. And this equals 9. So this problem requires a little bit more work. We've got to be really careful with the sign. And this negative 5 needs to be distributed over that addition. So when I do that, still left with this 4y minus now 20y minus 55. And this all equals 9. So now I can go ahead and collect some like terms and do an opposite operation in the same step. So I'm going to collect the 4y and the negative 2y because they're on the same side of the equal sign. I'm also going to do an opposite operation here. I'm going to add the 55 to both sides. And that will isolate my variable and move the constant to the other side. So I'm left with a negative 16y equaling, and I do this work, I have 64. And so now I just have one more step there. I just have to divide by that negative 16. Again, you got to make sure you're really careful with the signs here. One sign error will mess up the whole problem. So we divide by a negative 64, and 16 goes into negative 64 negative 4 times. So y equals negative 4. Well, from that point, we're still not done. We still have one more step, and that's to solve for x. Now we've got a choice. We've got 3 different equations here. We've got this one here. We could put y in for this one. We could put y in for this one, or we could put it in for the modified equation down here. Which one do you think would be the easiest one to put it into to come up with x the fastest? Well, if you said the third one, that would be correct, because all we'd have to do is substitute it in for this y and not do any opposite operations, just do some multiplication and addition. So let's see how it's done. So x equals 4 times by, and I'm using this equation here, instead of y, I'm going to put in the number y is, which is negative 4, and then plus 11. And so we go ahead and do that work. We get negative 16 plus 11. So x equals negative 5. So there's my answer. I write that as an ordered pair as negative 5, comma, negative 4. So let's take a look at the last one here. And that one, we end up having to do a similar step where we're trying to isolate one of the variables. So the variable If we look at the two equations, which one do you think would be the easiest one to isolate? Well, again, if you said the top one, that would be correct. The reason is that y is just about by itself here. All I have to do is move this 2x over. So the way I do that is I'm going to add 2x to both sides. So I'll go ahead and rewrite the new equation down below. And so it's y equals 2x plus 3. So all I did is move the 2x over, and I rewrote this part right here, this expression, positive 2x, positive 3. So now once you have a variable solved for, we can go ahead and do the substitution. We can take this 2x plus 3, and we're going to put it in for y in that second equation right here. And so we're going to rewrite the second equation, but in place of y, I'm going to put the expression y is. So we'll go ahead and rewrite our equation, starting with 2x, and then minus 3. Now you need to put the y term, what it equals, 2x plus 3, in parentheses, because it needs to be multiplied by this coefficient of negative 3. And this all equals 21. So we're going to go ahead and use that distributive property, multiply the negative 3 over that addition. And what we've got left is this 2x minus 6x minus 9 equals 21. So watch the signs here. Negative times the positive made that negative. So we're going to collect some like terms and do an opposite operation, just like the last problem. So combine these two terms. They're on the same side of the equal sign, so whatever the sign is, if they're opposite signs, I subtract, same sign I add. Over here, I'm going to do an opposite operation to get the constants onto the right-hand side. And so what's left over? Well, still have the x term. We've got now a negative 4x. Be real careful with the signs here. More negatives than positives. So negative 4x equals, and that makes 30. Well, when I go ahead and try that division, 4 is not going to go in there evenly. So I don't want to change it to a mixed number, because when I change to mixed numbers, I end up having to change back if I need to multiply or divide. And decimal forms give me more difficult numbers to deal with. It's easier to leave numbers in fraction form, believe it or not. And so we'll just reduce the fraction. So take out the common factor. So I'm going to take out a 2. Goes into those two numbers. So I'm left with x equals negative 15 halves. It doesn't matter whether the negative sign is on top, right in line with the fraction bar, or on the bottom. They're all the same number. Well, now we're going to use our substitution. We're going to take that negative 15 halves and put it in for x. And again, it doesn't matter which equation you use. You'll get the same equation or same answer for y with whatever equation you substitute in for. It's just a matter of which one is easiest. And so it's easiest to use this modified equation because we're trying to solve for y, and y is by itself. So then all we'd have to do is multiply x by 2 and add 3. So I'm going to take this negative 5 halves here, and it's going to be substituted into that x right there. So let's rewrite our equation with the negative 15 halves in for x. So y equals 2 times by negative 15 over 2, and then we'll add 3. Well, what's neat about this problem is that the coefficient of that fraction ends up canceling out the fraction. See, if you think of this as 2 over 1, these 2's will cross cancel. So all I'm left with is that negative 15 plus the 3. And so from there I combine those two terms, subtracting because they are opposite in sign, leaving me with negative 12. So there's my answer. Negative 15 halves, comma, negative 12 in parentheses. So that's solving using substitution. And our second half of the homework is going to be just a little bit of review, graphing using intercepts, and I'll probably also go over some slope-intercept form in part 2.